Hey there, Algebras. How you doing today? We are going to be trying something different today, and that is just notes. So we're going to go ahead and talk today about the GCF. And I know you've heard of the GCF in algebra, but I know you sometimes get that mixed up with the LCD. So the big question that you probably have is, what is this? Why are we doing it? And what does this have to do with polynomials? Okay, let's take a step back and do some review. And our review goes like this. One of the first terms that we learned in this unit was polynomial. And I like to think of a polynomial as just a collection of terms. Then those terms are separated by plus or minus signs. We always put our highest term in the front and decreasing terms as far as our powers go when we go down. We can then label these terms, and it helps us know the rules or what to do with them. And the first thing we do is we classify this polynomial by degree. So because we see this 2 there, that means that this is going to be a quadratic polynomial. Well, our next thing that we're going to do is we're going to classify it by the number of terms. And when we talk about the number of terms, if I have one term, it's called a monomial. 2 terms is going to be a binomial, and 3 terms is going to be a trinomial. If I have more than 3 terms, that's when we go back to it being a polynomial. So we take a look at these, and then we want to practice doing operations. So at first we talked about adding and subtracting, and then we realized that that was just really combining all of our like terms. So if I have a polynomial like 2x squared plus 6x minus 7, and I had another polynomial that I wanted to add to that, like negative 3x squared plus 10x plus 2, my job is just going to be to go ahead and look at each variable, because a like term is going to be values that are the same variable to the same power. So I can add this 2x and this 2x squared and this negative 3x squared together. These parentheses in this case are not necessary because my operation is addition. Because my operation is addition, I can go ahead and just add all of these terms. So when I see my x squared terms, my coefficients, remember, answer the question, how many? I have 2 and I have negative 3, so when I combine those terms, I add my coefficients. Positive 2, negative 3 is going to be negative 1. I don't write the negative 1, but I can, and I know that it's actually still there. All right. From that point, I go on and I look at terms in descending power. Here's my x to the firsts. Again, I don't have to write that 1 as their exponent. Here I have my x to the firsts. Here I have 6 of them, and here I have 10 of them. When I tally them up, I realize I have 6x to the firsts. My next job is to take a look at my constants. These are called constants because they have no variables. They actually have, if I wanted to think about it, an x to the 0 power. Anything to the 0 power is 1, so I don't even need to worry about that. Negative 7 as a constant, positive 2 as a constant gives me negative 5. So this whole polynomial as a final answer is going to be the opposite of x squared plus 16x minus 5. I've combined all of my like terms. So here we are for addition. Now we'll go ahead and do a subtraction problem. And the subtraction problems can be a little bit trickier. Let's say I have 10x cubes plus 7x squared plus 6, and I'm subtracting x squared plus 5x minus 3. Because I'm taking this entire expression away, I want to make sure that this negative sign lets me subtract each of these terms. The easiest thing to do is to rewrite each term in this second part as my subtraction. So I'm taking away an x squared, I'm taking away a 5x, and I'm taking away a negative 3, which is going to make that a positive 3. Once you understand why you're doing what you're doing, it's easiest to just go ahead and rewrite this second expression, knowing that you're subtracting. All right, so again, I'm going to go ahead through and I'm going to try to find each like term. Here I see x cubes, and as I look here, I don't see any more x cubes. So there are no like terms for this term. He just is there alone. All right, now I'm going to look at my x squareds, and I see I have an x squared here, and I have an x squared here. So it's positive 7, and remember this is a negative 1, which is going to give me positive 6x squares. Okay, now I have my constants. Oh, but wait, here I have my linear x's. I don't have any here, so this minus, here's this minus 5 x's are my next term. Now it's time for me to look at my constants, and when I look at those constants, I see positive 6 and I see a positive 3, and when I add them together, I get a positive 9. So now when I look at my final answer, I have 10x squared cubes plus 6x squareds minus 5x plus 9. Remember, when we write our final answer, we want it in SF. What does that stand for? Standard form. Okay, so we talked about adding, we talked about subtracting. Now here comes the fun one when we talk about multiplying our polynomials. I'm going to give you a couple of different scenarios here. So let's say that I have a 2x, and that is being multiplied by 3x squared minus x plus 4. We know we're going to need the distributive property, and your distributive property is the one that's going to say, hey, this 2x has to be shared out with each of these values in here. When we talk about the distributive property, sometimes we like to talk about the pizza man. And the pizza man brings pizza to the house, and when he brings pizza to the house, he's going to pass out pizza to everyone that's inside of the house. So that pizza is going to go to every single person. You wouldn't be happy if you ordered pizza and you didn't get any. So each of these little multiplication problems, I'm going to do 2x times 3x squared. That's going to give me 6x cubes. I'm going to go ahead and do 2x times x. And remember, that's negative. So that's going to give me 2x squared. And I'm going to give 2x to the 4, and that's going to give me plus 8x. So if we want to talk about what we have left as an answer, this is a cubic, because I have a cube here, trinomial, because I have 3 terms. So my final answer is going to be 6x cubed minus 2x squared plus 8x. So when I have one term, I can share it all out. The problem that we ran into, that we really need to spend some time talking about, is what if you have two expressions, meaning there's two plus or minus signs, one in each of these expressions. And this creates a new kind of conversation for us because we have to still honor our distributive property and our pizza man. So let's go ahead and give ourselves an example. Let's say we had 2x plus 6, and let's go ahead and say we have x minus 1. When our distributive property, when our pizza man comes, what I want you to think about is there are two people in the house, and the pizza man brings a piece of pizza, and let's say he brings a Coke. So what you want to make sure you remember is that this pizza has got to go to both people that want it, but guess what? This Coke also has to go to both people. So the pizza man delivers pizza to both people, and the Coke goes to both. In our notes last week, we talked about this process as FOIL: first, outer, inner, and last. We're going to multiply our first terms, then we're going to multiply our outside terms, then we multiply our inside terms and our last terms. Either way, we have to make sure that everything gets to every single person. So when I talk about FOIL, my first terms are my 2x and my x. When I multiply them, that's 2 times x is 2x squared. When I go ahead and I multiply my outside terms, that's 2x times negative 1 gives you minus 2x. Now I have my 6 times my x for my inside terms, and that's 6x. And then I have my last is going to be 6 times negative 1 is negative 6. Sometimes, but not all the times, these middle terms, your O plus your I, can be combined. So you want to always make sure you check for your like terms. Here I have 2x squared minus 2x's plus 6x's make plus 4x minus 6. My answer is a quadratic trinomial. So each of these operations is in the past notes. If you are a person who doesn't quite yet understand, go back and watch the past videos, because everything in math builds. And before you can do each next lesson, you need to know how we got the sum, how we got the difference, and how we're getting the products using the distributive property when I have a monomial or a binomial factor. Okay, so we'll turn the page and we'll take a look at and make sure that we date what it is that we're doing. And remember, this is week 3. We want to make sure we do this on our last page too, so we can keep track of our notes. All right, so our last operation that we wanted to make sure that we review is division. If I have negative 9y squared plus 27y, if that's being divided by negative, 3y. The way that we talked about it in our last video was to go ahead and divide each of these and distribute that division. So what we want to do is rewrite this as negative 9y squared over negative 3y. And this becomes plus 27y over negative 3y. So we distribute this division to both of these factors. So now it's just a matter of simplifying our fractions. We have positive 3y. And then this 27 divided by negative 3 is going to give me negative 9, and these two y's cancel out. So the interesting thing is there's another way to go about dividing, and this is our word of the day, which is we can factor it. So factoring becomes something we do in mathematics from now until you stop taking mathematics. So if I go back and I look again at negative 9y squared plus 27y, what I can do is take a look at what are the common factors. Now remember, a factor is a part of a multiplication problem. A factor is a number that's being multiplied. So do you remember when I told you about my factor triangles that my elementary school friends use with their kids? They would go ahead and they would put a 12 here, a 3 here, and a 4 here. So when the kids would study their math facts, they would cover up whichever one they needed to study. And they knew that 12 divided by 4 was 3. They knew that 12 divided by 3 was 4. And that 3 times 4 was 12. So what we need to remember is that these are the factors. And this is the product. That's the answer to our multiplication problem. Okay, so when we are factoring, we're looking for the factors. So what we want to do is think about anything that's common in both of these expressions that we want to divide out. And here's where we come up with our greatest common factor. So greatest means we're looking for the biggest. Common means it has to fit everything, and factor is it's a number that's part of a multiplication problem. So when I look at negative 9 and 27, I want to find the biggest number that comes out of them both. Well, I know that 9 comes out of 9. I also know that 9 comes out of 27. When I pull 9 out of 9, I'm going to get a negative 1. When I pull 9 out of 27, I'm going to get a 3. Now let's look at our variables. I have 2 y's here and 1 y here. The greatest number I can divide out of both is going to be 1 y. That's going to leave me with 1y, because this one was divided out. If I can factor my numerator, what I do when I divide, I have to bring back that denominator from that problem. And now this becomes a fraction I can simplify. Now what I might want to do is take a look and revisit this negative. If I divided a negative 9 out, that would leave a positive 1 and a negative 3. That way this negative will cancel out when I go to simplify my fraction. All right, so let's talk about what we can do. Y can be divided with y. Negative 3 comes out of negative 9 positive 3 times. So my answer I'm left with is 3 times y minus 3. I'm going to simplify those signs. If you take a look at this answer, I want you to see, is it at all similar to that answer? In fact, if I distribute my 3, I get 3y minus 9. So there becomes two ways of dividing. One where I distribute my divisor to both of the terms in my expression, and one where I look for and find a common factor that comes out, and then I can simplify that way. So the hardest part about using the greatest common factor is sometimes knowing what the greatest common factor is of numbers. So let's go ahead and practice some. If I have two numbers like 12 and 30, would you know the two numbers? What is the greatest of these factors? Now, if you're good with your math facts, you know that a 6 goes into 12 and a 6 goes into 30. So the biggest number that comes out of them both is 6. Well, let's say you didn't know that. What other options could we do? And this is what I want to bring you and have you see what Desmos can do for you. So here's my screen with Desmos on it. And did you see, look, if I type in GCF of 30, it gives me that answer 6. All right, let's try some other numbers. What if I wanted to find the greatest common factor of 3 numbers? What if I was thinking about 8, 24, and 36? Check it out. There's my answer right there on the screen. So if you're having a hard time with some of these coefficients, Desmos has the ability to give you some help with those factors problems. Remember to type your GCF, type a parenthesis, and separate your values with a comma. So you want to make sure that you have Desmos on hand, because when you're looking at numbers like I just said, 8, 24, and 36, you want to make sure that you know that 4 is the greatest common factor, or the biggest number that can be evenly divided out of both of these. All right, I've got one more example for you, and of course the third one is always the hardest. What if I had 4x cubed and 6x squared? Well, right away you're nervous because you're like, wait, what are you doing throwing in the variables? Well, here's why we're doing that. We have to consider these in two pieces. First, you find the GCF of your coefficients, and then you look at the greatest number of each variable that can be divided out. So if I took a 2 out of a 4 and a 6, that would be my greatest common factor. And if I brought 2 x's out, this one can handle losing 2, this one can't handle losing 3. So we want to make sure that we take out as many as we can without overloading or without taking too many out of one that we don't have. Okay, let's practice finding the GCF. So we're going to go ahead and write 2x squared plus 4x minus 8. So what I want you to look at each of these with my GCF, remember, I want you to find my greatest common factor. And guess what? You can follow along and have me do the work for you, but then what will you learn? So I want you looking at each problem first, and we'll look first at the coefficients. What is the biggest number that comes out of every single term? Remember, we have to go ahead and factor it out of each term. So because each term is even, I know a 2 comes out. So I can write my ideas over here. Now I look here and I know a 4 can come out of 4 and 8, but it doesn't come out of 2. So 2 is the biggest one that can be handled. So I know a 2 is going to come out, and I know when I write what's left, this is going to go to a 1, this is going to go to a 2, and this is going to go to a 4 because I've divided a 2 out of each. You can think of it as dividing. Okay, now we're not done. Let's check out those variables. I've got 2 x's here. I've got 1 x here, but no x's here. Since I can't take it out of this term, it's not coming out of the either 2. So guess what? All of those x's are going to have to stay because this guy didn't have any. So when I factor this expression, I've pulled out a value that was multiplied by every single term. This 2 was the greatest common factor. And if I wanted to, I could certainly put it back in. If I went back and did the distributive property, that 2 could go back in. In fact, what we learn is the distributive property and factoring are inverse operations. Because I can factor something that was distributed, or I could distribute something that was factored. So we're going to spend some time pulling numbers out and putting them back in. And the most important part of this is that you keep asking yourself, what is it that I'm doing? Sometimes we want to introduce parentheses. We want to insert parentheses because we want to break down a number. Our factoring gives us that ability to break down a number. Sometimes we want to use the distributive property because the distributive property has us simplifying. When we are factoring, we're introducing parentheses. When we're distributing, we're removing parentheses. So it's important for you to keep in mind, what am I doing and why am I doing it? Okay, let's do a couple more examples. Negative 3x squared, cubed, let's try that. Plus 6x squared minus x. All right, so if you look what I have here, it's a general rule of thumb that we don't like having a negative out in front. In fact, in our example back here, when we had that negative, we ended up going back and taking it out, didn't we? So that it could be divided. So our general rule of thumb is to bring that negative out. So when I go to find my GCF to factor, I know at least that -1 is going to come out. So let's take a look at these numbers. I've got a 3 and I've got a 6. Oh, now I've got a 1. Guess what? Nothing's coming out because all I have here is a 1. So even though this 3 and 6 were friendly numbers, guess what? This 1 makes it so nothing's coming out. All right, so my -1 came out, and that was it. My 3 is now going to be positive, and my 6 is now going to be negative, and guess what? This is now going to be +1 because I took out a negative. All right, let's take a look at those variables. I've got 3 here, and 2 here, and 1 here. What is the greatest number that I can take out? Yep, it's this 1. So when this 1x comes out, that leaves me with 2 here. That leaves me with 1 here, and guess what? That x divided out evenly, giving me just my 1. All right, so when I put my polynomial in standard form, I want to make sure that I have my -x Oh, I guess it's not in standard form because it's in factored form. I like that better. Negative x is on the outside, my 3x squared minus 6x plus 1. That's going to be my final answer. All right, let's do another example. We have 42x to the 8th minus 14x to the 5th plus 7x to the 4th plus 7d x squared. All right, so guess what? These are a lot of different coefficients. So I think I might turn to Desmos and see if that can help me out. So I'll go ahead and I'll ask for my GCF, and don't forget your parentheses, between 42, 14, 7, and 70. Oh, there it is. 7 is the biggest number that can come out. So I'm in good shape if I can think about taking my GCF as a 7 out. So before I go ahead and I write what's left in my polynomial, I think I'm going to take a look at my variables. So when I look at my variables, you can see I have 8 x's here, 5 x's here, 4 x's here, and 2 x's here. The greatest number of x's that I can take out is going to be 2. So those 2 x's are going to be divided out. Now, if you like thinking about that division problem, go ahead and turn this into a division problem. You can go ahead and write your greatest common factor underneath each term if that helps you look at and see what's left. When I divide out 42 divided by 7, when I pull a 7 out, that leaves me with a 6. 7 times 6 is 42. 42 divided by 7 is 6. I'm taking 2 x's away as factors, which leaves me with 6 x's. My minus sign stands. 14 divided by 7 is 2. 2 times 7 is 14. 14 divided by 7, when I pull it out, is equal to that 2. And I have 3 x's left over when I take 2 away from the 5 that are there. When I take 2 x's away from these 4 x's, that's going to leave me with 2 x's. When I take this 7 away from that, that leaves me with a 1. And if I want to write it, I can, or I can just leave it. 70 divided by 7 is equal to 10. And my x squareds will cancel out completely. So my 10 is going to be my constant. When I write my factored form of my answer, that's going to give me 7x squared, 6x to the 6th, minus 2x to the 3rd, plus x squared, plus 10. There's my final answer. All right, so that's all the notes for today with factoring out our GCF. You have a couple practice problems, and I'll post a sheet of those. You have a math space and an e-cart. So let's talk about your tasks for today. When we look at what I'm expecting you to do, first of all, do you have any review or makeup work? So just so you know, the quarter closes on Friday, May 1st. Anything you need, make sure that you email me, TJ Glazier fcps.edu and touch base with me about anything that you still need to work on for the third quarter. Week 1, you had to do a Desmos activity and you had to do an eCart activity. Week 2, I had you do a math space activity and I had you do an eCart. How are you on all of these things that you need to catch up? So this week, what I want you to do you're going to have, obviously, this video of the notes. Good job, you were doing it. Sounds good. Then you're going to have a math space and an eCart. If you are having a hard time logging on, or if you can't find where these things are located, make sure you email me so we can get you in good shape. All right, you guys, we'll see you soon in class. Bye-bye.